Okay, welcome to Chapter 1, Lesson 10, Compare Real Numbers. This is the last lesson for this chapter. So, woohoo, made it through the first chapter. Okay, our learning target or objective for this lesson is to compare mathematical expressions. And we do have a few vocabulary words to finish out the lesson. First one, irrational number. A number that cannot be expressed as a rational a over b, where a and b are integers and b does not equal 0. As always, you may pause the video to write down the definitions and proceed at your own pace. We're going to hit real numbers, the set of rational numbers and the set of irrational numbers together. We're going to look at a chart here in a second to show all of that, and that is only 2. Okay, we're going to move on to our key concept. Key concept is real numbers. Words, as we had earlier in the chapter, we had rational number. A rational number is a number that can be expressed as the ratio a over b, where a and b are integers and b does not equal 0. And now our new vocab word, irrational number. An irrational number is a number that cannot be expressed as the ratio a over b, and where a and b are integers and b does not equal 0. Example of rational numbers, we had them earlier, like a -2, a 5, a 3.76 repeating, or a -12 and 7/8. An example of irrational number is the square root of 2. 1.414213562 goes on forever and does not repeat. Goes on forever and does not repeat. That's an irrational number. Everything else would be a rational number. Let's take a peek at our chart that we have here. Okay, we're going to look inside out. So we're going to start with natural. Our natural numbers are 1, 2, 3, 4, and etc. all the way up to infinity. Whole numbers, all we do is add the 0 to our natural numbers, and that gives us whole numbers would be 0, 1, 2, 3, and on up. Integers, just go the opposite way on the number line. We're going negative numbers. So 0, -1, -2, -3, or if we go to the right of 0, 1, 2, 3, 4, those are all integers. And we get into our rational numbers, which we learned earlier in this chapter. We have our negative fraction, -4/3. We have our 1.3 with the line over it. That means that 3 is repeating, so it's 1.333333 forever and ever and ever. We have 11/2 fraction, and we have also fraction 3.79. Those are all rational numbers. And as we just learned earlier in this lesson, irrational numbers are numbers that go on forever but don't repeat in decimal form. Like we have pi, 3.14, etc., etc., etc. Square root of 3 and square root of 5, irrational numbers. And then all of those, rational and irrational numbers, are real numbers. So there we have it. And let's hit some examples. Fill in each circle with less than, greater than, or equal to make a true statement. Okay, if you have a calculator at home, this would be a good time to pull it out. If we're going to look at the square root of 7. Square root of 7, if we put that in your calculator, gives us 2.645751311. Excuse me for the writing there. That is the square root of 7. Or we have 2 2/3. That's not a negative, that's a 2 2/3. The system doesn't allow it to write it that way. 2 2/3, we put that in the calculator. Well, we have the number 2, and then 2/3 is 0.66666 forever. Okay, which number is greater? Let's look at our numbers. Well, our 2's are the same, so now we're in decimals. We have 6 is the same. In our 100 spot, we have 6 and 4. Obviously, 6 is greater than 4, so our 2 2/3 would be greater than, or how we write this, square root of 7 is less than 2 2/3. Hopefully remember how to write our less and greater signs. So square root of 7 is less than 2 2/3. Let's look at the next one. We have a percentage, 15.7% is equal to, less than, or greater than the square root of 0.02. Okay, remember how to write decimals From percentage to decimals, all we do is move the decimal point 2 spots to the left. So 15.7% becomes 0.157. Now, if you have your calculator, you can punch in the square root of 0.02. Square root of 0.02 gets you 0.141. Meaning, let's look at those. First number is 1, the same. Second one, 5 is larger than 4. So that means 15.7% is greater than the square root of 0.02. Okay, we have a few more we're going to do here. Actually, I'm going to have you do those at home. We'll go over those in class first thing. Make sure you understand those. And we're going to look at our railroad example. What we got here? On a railroad example, on a clear day, the number of miles a person can see the horizon is about 1.23 times the square root of his or her distance from the ground in feet. Suppose Frida is at the Empire State Building observation deck at 1,250 feet, and Kia is at the Freedom Tower observation deck at 1,362 feet. How much farther can Kia see than Frida? Okay, so let's look at what it says. 1.323 times. So let's do, first was Frida. 1.23 times the square root of their distance up, and her distance is 1,250. So we put that in the calculator, 1.23 times the square root of 1,250. We get about 43.49. Remember, about is two little squiggly lines. If you don't have a perfect square, you're going to get a number that goes on forever, so that's why we sort of round it. We say about. So she is 43.49 miles, Frida can see, being in the Empire State Building. Now, Kia. Kia has the 1.23 times the square root of where she's standing, and she's standing 1,362 feet above the earth. We put that in our calculators, and we estimate that she can see approximately 45.39 miles. So how much farther can Kia see than Frida? We have 45.39 minus 43.49. There we go. 0, 1, 9. About 1.9 miles farther. Okay, any questions? You may write them down, review the video. Okay, as I said, this is the last lesson for Chapter 1, so we will be preparing to study and take Chapter 1 test.